Hello, this is GCSE Physics Explained. I'm going to tell you about radioactivity and balancing radioactive equations. So we'll start with the basic structure of an atom. So this is your atom, drawn over here. That's your nucleus. The nucleus contains the protons and the neutrons, and the electrons orbit around the outside. So they are the three subatomic particles inside an atom. Now you need to be able to tell the examiner that the electrons, what the mass is. So it's very small. It's what we call negligible. I'll come back to that in a second. We see that the mass of a proton and the mass of a neutron have got a mass of 1. Okay, the real life number is very, very small, so they've just standardized it and said 1. So when I'm saying the mass of an electron is 1 divided by 1840, it basically means it's like nearly 2,000 times lighter, the electron is, compared to a proton and compared to a neutron. Now that's the masses all done. You need to know what the charges are. So the charge on an electron is -1. The charge on a proton is +1, and the charge on a neutron is neutral. So that is the structure of an atom taken care of. Right, this is going to go a little bit sort of chemistry. You've got to know what these two numbers here mean. So X just represents any chemical symbol. Alright, now when you're looking at the chemical symbol, there'll be a number up the top. That's A. That's called the mass number. So now the only thing that's got mass, remember there's 3 subatomic particles in an atom: the protons, neutrons and electrons. But we've already said the electrons have got like negligible mass, which means it's so small you can forget about it. So this mass number is basically made from the number of protons added to the number of neutrons. This number here, this Z number, is the atomic number, and that's the number of protons, and that defines the element. So if the number of protons changes, basically it means that the atomic number is going to change, and that helps us to tell what chemical it is. So the atomic number tells you what chemical it is. So in the periodic table, like hydrogen's 1, got an atomic number of 1, so that means it's got 1 proton. Helium's got an atomic number of 2 because it's got 2 protons, and then lithium's got 3, you know, blah 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 as you go through. So let's get back to this number. So hang on, that number there, the A number, that tells us how many protons and neutrons there are, and that bottom number tells you just the number of protons. So to work out the number of neutrons you've got, all you need to do is A take away Z. So like just say that was 40 and that was 18. So 40 take away 18 is 22. So that would mean there's 22 neutrons and 18 protons. Right, types of radiation. So there's 3 types of radiation. You've got to tell the examiner. This squiggly thing here means an alpha. It's like alpha, it's a Greek letter of the alphabet. Beta is a Greek letter of the alphabet, and so is gamma. Beta is like just a normal capital B, but it's got a long wiggly tail. And gamma is like a fish diving into some water. So what is an alpha? Basically it's 2 protons and 2 neutrons, so it looks like that. Now you know that protons have got a mass of 1 and neutrons have got a mass of 1. So the alpha particle's got a mass of 4. Now there's no electrons knocking about. So helium, which is number 2 in the periodic table, it's got a mass of 4. So it would normally have 2 electrons orbiting around the outside, but an alpha particle is just like a helium nucleus. So it's it hasn't got the electrons around the outside. A beta particle is basically like a fast moving electron. It's got a negative charge, it's got no mass. Right, I'll get to that in a little bit. And a gamma has got no charge and it's got no particles, so it's just pure energy. Gamma, remember, it's an electromagnetic wave, so it's just like a wave. It's got no energy. Right, so let's get down to splitting up the nucleuses. Don't say splitting up the atoms. During radioactive decay, a neutron splits up into a proton and an electron. So a neutron, which has got no charge, but it does have a mass, it's going to split up. Now remember, a proton has got a mass, so that's like where the neutron's mass goes into the proton, but the neutron's neutral. So look at this. If you add a proton to an electron, that's a plus and a minus. That equals 0. So a neutron is like a proton and an electron added together, and it's just the neutrons splitting up back into a proton and back into an electron, if you like. Here's a quick equation to do with beta decay. So if you've got like carbon 14, 6, now the examiners, they don't expect you to remember all of these elements, so just basically forget about them. But what you do is you need to do like a basic maths. Just say this was missing, okay, and all they gave you was that and that. So you just need to know that whatever these numbers here on the right are, on the top, they need to equal that number on the left of the arrow on the top. So if that says 14 and that says 14, then that has to be nothing, because nothing plus 14 is like 14. And if this number here was missing as well, so this is number 7 and that's number 6. Okay, so that bottom number on the left of the arrow has to equal these two numbers on the right of the arrow. So what you need to add to 7 in order to make 6, well, you need to add a minus 1. Okay, minus 1 plus 7 gives you 6. Right, let's have a look at a few examples. Again, just forget about that uranium stuff, alright? You don't really need to know the symbols. All you need to know is this number here, 238, alright? That's the number on the top, and there's a number on the bottom, but it's missing. And when you add that number on the top on the right to this number here on the right, so that number there plus that number there has to equal that number there. Alright? So what do you need to add to 234 to make 238? You need to add 4. Alright? Now this one here. Now actually we know that helium, right, is a 4-2. Right? Alpha looks like that. 4-2. Right? These are the keys to the kingdom, right? Beta, that's got 0 mass. It's got a charge of minus 1, right? So this top number tells you the mass, and this bottom number tells you the charge, alright? And gamma, it's got 0 mass and 0 charge. So, but these are all alpha decays anyway. So to be honest with you, every time it sort of says a helium, you can just put in a 4-2. But yeah, so that I think that's, they will assume, the examiner, that you know that. Right, so a helium nucleus is basically an alpha particle. So, right, check it out then. So we've got 218 and 4, and that has to equal whatever that number is there. So basically that number there is just going to be 222, isn't it? Alright, 218 plus 4 gives you 222. Is the bottom balanced? So I've got an 88 there, and then it's going to turn into like an 86 and a 2, so 86 and 2 is 88. Well, yeah, that's fine. I mean, these are easy once you get into them. All right, just like anything in life, when you're first looking at something, it looks chaotic because you can't see the patterns. All right, but once you spend enough time doing something, you can start to spot the patterns. It's like if I gave you £500 and said, get yourself onto the stock exchange market, right? You wouldn't have a clue what you were doing, so you'd just waste your £500. But if I gave £500 to someone who goes on the stock markets every day, they'd know exactly where to invest their money because they can see the patterns, you know, when stocks move up, when stocks go down and all that type of stuff. So Right, let's do a few more of these so you can start to see the patterns. Right, so that's 208, that number there on the top on the left of the arrow. So when there'll be a number here and there'll be a number here. Now we know that helium is 42, so I'll just stick that in straight away. Alright. Now what you need to add to 4 in order to make 208? Well, it must be 204. And this thing here, what have I got to add to 2 to make 84? Now that one there must be 82. It's easy, isn't it? Hey, check it out here. Well, you don't hardly have to do anything here because I know that helium is 42. Right. So they are alpha decays. Now let's have a little look at some betas. Alright, so these are some beta equations. Now remember, beta particle is basically an electron. It's got 0 mass. It's got a charge of -1. So there it is. Right, so sometimes you can just see it literally as written like an electron there, E for electron instead of B for beta. Right, now these are a little bit more tricky because I'm dealing with minus numbers. Right, but the rules are still the same. So whatever that number is on the top left, when I add these numbers on the top on the right, they have to equal that one. Alright, so 234 plus naught gives 234. Right, what about here? There's a number missing down the bottom there, isn't there? So what have I got to add to -1 in order to make 90? Right, well, 91. Alright, so 91 plus -1, well, that's going to be 90 then, isn't it? Right, what's missing over here? So that's 131 on the top left. So when I add that number there to that number there, it has to equal 131. So I probably just need to speed up because you're probably getting a bit bored by now because it's so easy. So that must be 131 plus now it's 131, and then 54 plus -1 is 53. Well, aye, that's fine. Here we go. So what do I add to nothing in order to make 6? Well, that must be 6. What do I add to -1 to make 2? Well, that must be 3 then, isn't it? So 3 plus -1 equals 2. Yeah, that's right. And then, oh, look at this. Right, well, they've tried to trick us. They've left a few numbers blank here. That's easy. So we know that our little electron has just got no mass. That top number's the mass, remember? And the bottom number's the charge, so that's -1. And then, right, so 24 plus nothing is 24. And 12 plus -1, well, that's just like 12 minus 1 then. So that's 11. Alright, so that's how to do that little bit. Now here we go, alpha or beta. You decide. Alright, so what's this? 201.79 is going to decay to 201.80. Right now, let's write it out down here. So 201.79 AU, right? That is going to decay. It's going to turn into 201.80 Hg. I mean, don't worry about Hg. You don't have to remember any of these daft symbols. But what we need is a number here and a number here. So what have I got to add to? Well, that's 201. It's already 201. So that's nothing. 201 plus nothing is 201. And how do I go from 80 down to 79? Well, it's like a -1 then, isn't it? So there you are, must be our little electron. So that one's the beta. Right, what's this thing? I'll just speed it up. So 231.91 is going to go to 227.89 plus what? Right, so what do I need to add to 227 to get to 231? Yep, I need to add 4. What do I need to add to 89 to get to 91? 2. So that's our alpha, wasn't it? That's our alpha. And this bad boy, so 185 to 79. We just like pause the video, you have a shot of it, right? And then turn the video back on and see if you've got it right. So that's going to be added to what? So hang on then, so 181, yeah, I need to add 4 to that to turn into 185. That's 77. I need to get to 79, so that must be 2. So that is also our alpha in this thing here. So what's this one? 5226 Fe is going to turn into 5227 CO, and something else is going to happen here. Well, you can spot the patterns. Look at that, man. 52. I've got to add nothing to 52 to make 52. What do I need to add to 27 to get to 26? Minus 1. 18 there. Alright, so that's our beta decay. Alright, so yeah, you must be getting the hang of that. That's easy, isn't it? Right, I've just got one more little thing that I want to show you, right? And it's this. They'll ask you about the properties of nuclear radiation. So your alpha, your betas and your gammas. Alright, well, it'll ask you about the penetrating power, so it just means what can it go through. So from highest penetrating power to lowest penetrating power, you got your gamma, your beta and your alpha. What is penetrate? So alpha, right, is very low penetrating power. It's useless. Can't even get through a sheet of paper. Alright? So in an exam they'll say, how do you stop alpha? And you just say, put a sheet of paper in the way. And then they'll say, how do you stop beta? Well, beta goes through paper, so it's a bit more penetrating. We get stopped by thin aluminium, so a thin sheet of metal. And your gamma, well, gamma is just pure energy, so it's very difficult to stop. You know, goes straight through paper, straight through aluminium, and it needs a big thick sheet of lead to stop it. Lead is very dense material. They'll ask you what the ranging air is. So basically gamma is like infinite, just keeps on going until it like smacks a piece of lead or very thick concrete. Beta can travel about 1 or 2 meters in air, and your alpha travels about 1 or 2 centimeters. Because remember, alpha is like really big and heavy, isn't it? That had like a massive 4, so that's like dead sluggish. Beta was light, wasn't it? So that can travel like faster, like a little whippet. And gamma is, well, it's got no mass, no charge. It's just pure energy, no mass. How is this? You know, it's going to be difficult to stop because you can't even sort of grab it. You know. Right. And finally, the ionizing power. All right. So penetrating power, and then now I'm telling you about ionizing power. So alpha is very ionizing. Beta is the medium ionization power, and gamma is the lowest. Now, what do I mean by ionizing power? Well, when something gets ionized, it loses electrons. So usually after being hit by something. So usually an alpha, beta or gamma. So remember, this is what your atom looks like, isn't it? It's got your little protons and your neutrons tucked in the middle. And orbiting around the outside is your little electrons, right? If you ever wonder how does that stay there, well, that's negative and the proton's positive, so it's like opposites attract. Alright, it's not gravity keeping it there, it's an electrostatic force. So what happens is, if something gets ionized, right, you use your alpha particle, dead big and dead heavy, and it just comes along, smack, and it knocks that electron, whizzes that off. So that was originally an atom, because it might have had like, you know, 2 electrons, so that's 2 minuses, and that was because it had 2 protons, 2 positives. So remember, however many protons it's got, that's how many electrons it's got as well, because an atom has got no overall charge, it's got a charge of 0. So now if this alpha comes along and smacks that electron off, well, now it's only got like 1 electron, so 1 minus, and it's got 2 protons, so 2 positives. So overall it's now got like a charge of +1. So that is no longer an atom, that is now an ion. So an ion is basically an atom that's lost or gained electrons, and now it's got an overall charge instead of like 0 charge. So alpha is really good because it's dead big and heavy. It's like a heavyweight boxer. Smack, it knocks that electron out of the orbit. Beta is like very light, so that it can hit the electron and it does ionize a little bit, but you know, it's not very big and very heavy, although it does move fast. So it cannot knock that electron off very easily. And gamma is just like fresh air, isn't it? I mean, I'll tell a little story. Your brain's quirky in the way that it likes to worky. if you can come up with some kind of story, you'll be able to remember things easier. So in order to remember the ionizing power, I tell my students a story about, imagine you've got like 10 pin balls, alright, so you must have been bowling before. So you've got your little 10 pin balls like that, right? Now alpha is dead big and heavy. It's like a great big bowling ball, where now if I chuck that bowling ball down, smack, it's going to knock all those pins down, okay? So however many pins it knocks down, that's how good it is at ionizing and like knocking electrons off an atom, if you like. So the alpha is like a bowling ball, dead big and heavy, so that knocks the pins down easy. Beta is like a little grape or something, right? It's just like this tiny little thing. If I set the pins back up, right, if I fling that down, it's going to make, maybe it's not one pin down, you know, so like it might knock like one electron off, you know, going back to me, going back to the reality instead of looking at me metaphor. Gamma has got no mass at all, so imagine I pulled out some fresh air and I bowled some fresh air at the pins. Well, that's not going to knock them over, is it? So it's like gamma, it's like that's not going to knock any electrons off, is it? So if it can't knock any electrons off, it's not going to ionize anything, is it? Oh, so not very easily anyway. So gamma has got a really low ionizing power. And yeah, that just about summarizes it. So that takes care of business there. Thank you very much, and goodbye for now.